Hi, and welcome back. Many of my podcasts leading up until this point were actually of the pre-algebra nature. So the beginning of algebra is right about here. So this is really where beginning algebra starts, verifying solutions to equations and using formulas to solve problems. So today I want to talk about the problem-solving process. A lot of students are sort of intimidated by word problems, but I want to take that away, that intimidation factor. So first, to determine whether a value is a solution to a given equation, simply replace the variable in the equation with the value. And if the resulting equation is true, the value is a solution. So the first thing I want to practice is let's just verify whether a particular number is a solution to a particular equation without actually solving the equation. So because we haven't talked about that much yet. That's coming in the next series of podcasts. So for now, a lot of people say, wow, should I just plug -3, like plug and chug? Plug -3 in for x, crunch that out, see if it comes to be true. So a lot of algebra, and chemistry for that matter, is this notion of balancing an equation, always keeping a balance in mind. So let's see. 6 times -3 is -18 plus 5. Does it balance with -13? Does it come to be a true statement? Well, -18 plus 5 is -13. Aha! And -13 equals -13. That's a true statement. So, is -3 a solution to that equation? Yes. The answer is yes. Okay, and we didn't actually have to solve it to know that. We just did a little bit of plug and chug. Okay, let's see what's next on the agenda. So I page down and I see I do have one more example for us to work out here. It says check to see if -0.2 is a solution to the following equation. So that's just one more for us to practice doing the plug and chug. So is -0.2 whole thing squared plus 0.7 equal to 1.4? And it's really just us checking to see if that's true. Well, -0.2 squared, you can go off on the side. When you square something, it means that thing times itself. So you're really taking -0.2 times -0.2, which, is 0.04. It's going to be positive. Negative times a negative is a positive. So we have 0.04. At this level, a lot of you are using calculators. That's fine. Or you can do it by hand. So 0.04 plus 0.7, does it equal 1.4? And this is a question. Okay? Well, 0.7 plus 0.04 is what? 0.74? Aha! So readily, we could see that 0.74 does not equal 1.4. So check to see if it's a solution. Note to self, not a solution. That's all you'd have to say. Not a solution. Doesn't check out. Doesn't verify. Okay, we are about to do some word problems together, but I wanted to read you the problem-solving process before we do that. And you can Google this person, George Polya, Polya's problem-solving process, if you like, but I'm going to summarize here. Number 1, understand the problem. Read the question. Not the whole problem, just the question at the end, and write a note to yourself about what it is you're trying to find. Read the whole problem, underlining the key words, and if possible or useful, draw a picture, make a list or a table. Let me say that again. Make a list or a table or organize what is known and unknown. Simulate the situation or search for a related example problem. Then you plan your solution by searching for a formula or using keywords to translate an equation. Then here in number 3, you execute the plan by solving the equation or formula. And then you, in number 4 here, you answer the question and you look at the note about what it is you were trying to find. So I always say go back and double check what exactly were you trying to find and answer the question and use the appropriate units, especially if it's area or volume or perimeter you're looking for. Step 5, check the results. Find the solution in a different way, perhaps, reversing the process or estimating the answer just to see if your answer is reasonable. Okay, let's go for it. First thing we're going to do is look at using formulas. I'm sure you're familiar with this already, but when you're using a formula, you replace the variables with the corresponding given values and you solve for whatever is missing. I also wanted to mention that since this is a beginning algebra class, a lot of people wonder what geometric formulas they'll be responsible for. If you're climbing the rope of mathematics and you're going up and up and up, we have to assume that you've memorized some certain things. So I'm going to circle here. Perimeter and area of a circle. You know, area and perimeter of a rectangle. Like area equals length times width. Perimeter is twice the length plus twice the width. Parallelogram, base times height, area. Area of a trapezoid, 1/2 h b1 plus b2. Okay? Area of a triangle, circumference and area of a circle. So those are the ones I'm going to hold you responsible for it on a test, meaning assuming you've memorized those. Okay, let's see what else. If you need to pause the recording and jot these formulas down, but they'd be easy to track down in any textbook or online, but here they are. You'll also be responsible for volume and surface area of a box, okay? Volume of a pyramid, 1/3 length times width times height. Volume of a cylinder, volume of a cone, and volume of a sphere. At some point, we have to assume that you've devoted these things to memories, or, you know, otherwise people would land in calculus and still not have all this under their belt. So, okay, let's play. Now remember, the author isn't going to blatantly tell us what to do. We just have to think about it. Number 1, a kennel owner is enclosing a rectangular area. First thing I'm going to do is highlight rectangular area with fencing. And you know, draw. As soon as I see that word rectangle, I'm going to start drawing with fencing. The kennel is going to be 60 feet long and 25 feet wide. What is the total amount of fencing needed? And disregard a gate. So I'm going to draw this in another color. Will I be needing perimeter of a rectangle or area of a rectangle? So note to self, fencing, well, your distance around the object, we're going to be looking for perimeter here. And by now, I'm sure you're aware that perimeter, note to self, means add all sides of your polygon here, which here there's 4 sides. Okay? Area is the interior space, and we're not interested in that. We're interested in the fencing going around the object. Okay, so I'm sure you probably added that up on your own by now. So 25 plus 25 plus 60 plus 60. Hopefully you're thinking 170. Remember the units? That's plain old feet. So perimeter is feet, you know, area, if it would have been area, is units squared. Would have been square feet, and volume would have been cubic feet. Something to keep in mind when you look up a perimeter formula, it's sometimes written as twice the length plus twice the width. Well, that's really what we did here. 2 of these plus 2 of these. Okay? I like to think of perimeter as add up all the sides. Okay, hope that helps. Let's try another one. In this next problem, it says a circular window is to be covered with an applied stencil. If the window has a radius of 3 feet, how much of the window cover is needed? Well, again, I'm going to grab a different color here. Again, we have to think about, you know, drawing, excuse the imperfect circle there, my feeble excuse for a circle. Let me try and make that a little bit prettier. Okay. A couple things you have to remember. Radius. Hopefully remembering radius is the distance, you know, from the outer edge of the circle to the center. So you've got a radius of 3 feet. Okay. And then we're applying, it says the circular window is to be covered, keyword covered, with an applied stencil. So it's like I'm covering all of this. Okay. So what is that? Well, that's area. It's not perimeter. Distance around the circle would be perimeter. So to grab the right formula, area is pi r squared. Okay? From there it's plug and chug. Pi, I'm sure you're aware, is 3.14 times the radius squared. Now you can go ahead and crunch that out on your calculator. So or you could do it by hand, but 9 times, I'm going to use my pi button, you can use 3.14 if you like, about 28, it doesn't say where to round, so we'll say about 28.3. So approximately 28.3, and remember the units on that, you're dealing with area, so the square footage. You can say feet squared, or you can literally write square feet. Okay? So a lot of people say the tough thing is them deciding what formula. Well, just remember, area is that interior space on the object, on the two-dimensional object, and perimeter would have been as if I'm walking out around the circle, and it doesn't say anything about that. Okay, hope that helps. Let's try another. In this example, we sort of have two calculations nested in one. I'm going to note to self here. I like to think of this as a composite figure. It's almost like two figures in one. The following is a drawing of a deck that is to have a brick flooring installed. So, calculate the area of the deck. Well, you're looking at this, hopefully you're looking at this thinking, wow, that's a rectangle with looks like a semicircle on top of it. And that's true. So really, I'm going to write this in words. We're going to get the area of the rectangle plus the area of the semicircle. Well, the area of this rectangle here, hopefully you're thinking, is length times width. I should have written that in another color, but length times width. And it might help you to lay out those formulas. And the area of that semicircle, well, that'd be like a full circle, pi r squared, cut in half. So I'm going to write here semi. Now the question is, though, I'll do this in another color. What is the radius of this semicircle? So from here, it's being fussy, from here on out, here to here. Well, from here to here is 6 feet. So, halfway then across the circle would be 3. So note to self, radius equals 3. Okay? So we know that we're going to take pi times 3 squared and sort of cut that calculation in half to get the area of the semicircle. All right. And let me fill in some blanks over here. To get the area of the rectangle, we know we're just going to take length times width, so that won't be hard. So 12 by 6. So we'll add the area of the rectangle plus the area of the semi, and we will get the total area. I'll hit pause as you do that. Okay, so hopefully you crunch that out, and you got 72 plus basically 9 times pi divided by 2. And hopefully you typed that out okay, and you got approximately 86.1, depending, where you're rounding. Approximately 86.1, but how about those units? Feet squared, right? Area. So we can just write square feet or feet squared. All right. Hope that helps. Let's try another one. Because remember, that was getting you the total area of the rectangle plus the total area of the semi, and that's basically what we did. Sometimes with figures that look like a composite figure, you're not adding two areas together, you're subtracting. And that usually is involved when you're trying to find a shaded area or exclude a shaded area. So let's take a look at this example. So I'm just going to kind of note to self here. This one, we're going to have to subtract a particular area. All right, a family room is going to be carpeted. Determine the area. In fact, I want to get mine carpeted here in a moment, and I have to go out around the fireplace area. It's going to be carpeted. Determine the area to be carpeted, excluding the area of the semicircular hearth of the fireplace. Yeah, it's actually happening to me. I'm going to get an estimate in a couple days. So what we see here, the area of the rectangle alone, I'm going to write this in words as area of the rectangle. The area of the rectangle alone is length times width. So from here to here you see is 12. From here to here you see is 14. So 12 by 14. So let's crunch that out. 168. So the area of the rectangular region alone is 168. square feet. I'm just going to write here square feet. But clearly we're deducting out that semicircular region. So over here I'm just going to write the area of the semi. Well, that would be pi r squared divided by 2. The area of a full circle, cut in half. Well, the only problem is we have to think about what the radius of that little circle is. So let's see if I can draw it. Okay, I think it's going to give me a little wiggle room here. The drawing is trying to illustrate that from here to here is 3. From here to here is 3. That makes 6. So how much is left over from here to here? Well, 14 is the total, distance of this wall. So basically, if this is 3, and if this is 3, that makes 6. You got 8 left over for that vertical distance. So we know that's 8 feet. Now I'm going to do this in another color. But the radius is only it's just halfway through the circle, from the center to the outer edge. So what's that, little red radius there? Well, half of 8. So that's 4. So 4 is the radius. And that's what needs to go into that expression right there. Okay? So let's take a moment to crunch out, 4 squared times pi divided by 2. And we'll put that, we can even put that over here. Pi times 4 squared is something divided by 2. I'll hit pause and you crunch that out. Okay, so hopefully you got the area of the semicircle to be about 25 units, about 25.1. So if we're only carpeting this area in here and we're neglecting that semicircle, we need to take I'm going to write it in words, you need to take the area of the rectangle minus the area of the semi. So you're basically taking that 168 minus whatever you got when you typed this out, which was about 25.1. Okay, survey says the area of the rectangle is 168, the area of the semicircle was 25. We subtracted and to get the area needed, and we got about 142.87, approximately, depending on where you rounded or depending if you use the pi button or not. But if you're in the ballpark of 142.87, and again, that would be square footage, square feet. Okay, hopefully you're getting a little more comfortable now. So now let's try one where we are not using a geometric formula. We're either A, using common sense, or using some formula that's given. So this one involves non-geometric formulas. A truck driver begins with a delivery at noon and travels 120 miles before taking a 30-minute break. And then he goes 136 miles, arriving at his destination at 5 p.m. What's his average driving rate? Well, we're given the distances and the times, and we're told to find rate. So we make a plan. We know from driving a car that, distance equals rate times time. But that also means that rate equals total distance. Average driving rate would be total distance over total time. I'm just going to write distance over time, which is what I have here. So we first need to total the distance traveled and get the total time spent driving, and then we can use that relationship. Okay, so what's the total distance traveled? Well, 136 miles and then the 120 miles. So I'm going to write that here, 136 plus 120 divided by, now we got to get the total time. Now this is a little tricky. He started at noon, okay, and he arrives at his destination at 5, which sounds like he took 5 hours to get there, but he took that 30-minute break. So how long was he actually traveling for? Not 5 hours, but 4.5. Okay? Okay, so by now you are seeing that the rate was the total distance divided by the total time. So we got about 56.88 for the rate. Okay? And again, you have to take into consideration that 30-minute break. So if he left at noon and arrived at 5 and went straight through, he would have been traveling for 5 hours. But he took that 30-minute where he just sort of sat still. So really only took him 4.5 hours. So just to reiterate, we took the 136 plus the 120 total distance divided by the total time it took to travel that distance. And that's what got us to this answer. And that you can just write here mph, miles per hour. All right, hope that helps. Okay, and now just for grins and giggles, in my class, these are meant to be with the clicker system, but we can solve them together. It says determine which of the following is a solution for the equation. So now that we've listened to everything, let's try and summarize. You can hit pause now and try this on your own, or you can do it with me. By now, some of you know how to solve the equation. Remember that we could plug each one of the results into the equation and see if it's true or not. So for example, I'm actually going to start backwards and store 4 in. Is it true that negative 6 times 4 minus 4 plus 2 balances with 4 times 4 plus 3 minus 6? Well, 4 minus 4 is 0, and 0 times anything is 0. So on this side we have 0 plus 2 equals, over here, 4 plus 3 is 7. 7 times 4 is 28. So that's not balancing. That's like 2 equals 22, not balancing, not working. And like I said, you could go through that process of elimination, or, in our next podcast we're going to talk a lot about solving anyway. So you could actually solve the equation for x. So negative 6x plus 24 plus 2 equals 4x plus 12 minus 6. Excuse me. Combine like terms, negative 6x plus 26 equals 4x plus 6. We can balance the equation. We're going to be playing a lot with this in the next couple podcasts. So here we have negative 10x. Actually want to move 26 to the other side of the equal sign, so I'm going to subtract it off. That's called the add-up property of equality. 6 minus 26 is negative 20. And then right at the end, you're dividing by negative 10 to solve for x. So negative over negative is a positive. And yay. Survey says answer is 2. Okay? So like I said, you could actually solve it, or you could plug 2 in to see if it balances. So you see it's circled 2. And this will be our last one together today. A thermometer reads 30 degrees Celsius. What is the temperature in degrees Fahrenheit? Well, they're giving us the Celsius, so hopefully you're thinking that we're going to plug it in, okay? So Fahrenheit equals 9/5. That would be times 30 degrees plus 32. By the way, when you see 9/5 right beside a set of parentheses like that, that means multiply. You can do it by hand or on your calculator. 5 goes into 30 6 times. 9 times 6 is 54, plus 32 will lead us to Fahrenheit. So hopefully you're thinking 86. And we'll see what the clicker system agrees with us. Yay, 86. All right, guys, good luck out there.